Welcome to a new episode in the Multiverse video series. Today we're going to learn how to use dplyr and Spark to process large datasets in your local computer. This means you're not going to need to use an actual Spark cluster with a bunch of nodes and what usually can be a complicated setup, but we're going to find how to use Spark on a real use case where you may have a significant amount of data that you need to process and where it either doesn't fit in RAM or where using RAM is unfeasible for different reasons, but where Spark can actually help you perform those operations all in your disk drive without having to use almost any memory. All right, so today's video was actually inspired by a tweet a couple hours ago. So someone was mentioning that they were having trouble performing an inner join with dplyr. And in this case, it looks like the dataset is quite large. It's a 2 GB dataset. And they're basically trying to inner join these two datasets. And apparently, dplyr wasn't being as efficient. I didn't reproduce it whatsoever. But what this made me think of is that you can, this type of problems could be also a problem that Spark can help you solve. Now, I usually don't recommend using Spark on a single computer because Spark was designed to be used in a cluster environment. That means with multiple computers. But there's a few use cases where Spark can actually be quite performant when using a single machine. So why is that? Well, just to give you some context, Spark, has been competing in what we call in computer science sorting competitions. So basically, the idea is that like ordering a set of files with either numbers or data, arranging that either alphabetically or numerically or whatever. It's one of those operations that are pretty important when dealing with data because you usually need to sort data for a lot of reasons. So, competing in these competitions where, frameworks like Spark and others can focus on very specific problems that are somewhat idealized, but also tend to be quite useful in practice, like it makes sense. And one of the things that people don't know a lot about Spark is that while if you search here Spark, well, first of all, Spark has been one of the past winners for tools that are able to sort data really fast. And most people think of Spark as in-memory processing, which is one of the big use cases for Spark. However, Spark actually, when they compete in these competitions, they actually do a lot of disk processing, just because the data is so large, and memory helps to perform the sort more efficiently, but it also supports kind of like disk-based processing. Anyway, so kind of like this is just to give you a sense of why Spark can be considered also on when dealing with data sets that are only in your local machine. And this particular issue that we're going to explore is an inner join. So the way that inner join works in dplyr is pretty straightforward. You give it a data set on the left side and a data set on the right side. Well, doesn't matter, it's two data sets. And then you define how you want to join those two data sets together. By how I mean which column you use to join them. And if we look at the Wikipedia page of just in general data analysis and SQL processing operations, they have a nice diagram here of how an inner join looks like. Here is a Venn diagram basically representing the inner join. So you basically have two data sets, left and right, and you're looking for those keys that are the same in both of them to actually retrieve and do something with them. So I don't know exactly for this particular problem that I found in Twitter. I don't know exactly what was the inner joins specifics, but at least we can try doing this with Spark and inner joins, and somewhat idealized, but it should give us a sense of what we can do with Spark. in a local machine. All right, so it would be good to mention that my machine in this case only has 8 gigabytes of RAM, so it's not like a huge machine whatsoever. And before I started this video, I prepared 3 files. And let me show you how I prepared these 3 files. So I created basically, like a few random numbers that are generated between, I guess, 0 and 1 billion. And yeah, basically it's a matrix. It contains 10 columns and a bunch of numbers. And yeah, I generated files they're not exactly 2 gigabytes. I left it on 1.6 gigabytes because whatever. But the interesting thing here is that you can see on the files pane is that there's actually 2 files. One is called large file 1 txt, and the other file, which is actually a folder, but it contains inside the file. The other file is called large file 2 txt, and it also has 1.6 gigabytes. And just to make our life easier, I also created a little file with just 100 numbers, 10 rows and 10 columns, which is 1.7 kilobytes. Just to make sure that we can load this easily and make sure that the join works and why not before we actually use the large data set. All right, so if you try to do this in dplyr and even loading this into memory, it takes takes quite some time just to load it in memory because it's 1.6 gigabytes and it needs to get transformed and all that, which can be quite expensive. So what we're gonna do instead is we're gonna use just Spark. If you don't know how to install Spark, you can look at some of our previous videos. There's a video on how to install Spark and why not. What we're gonna do here is first of all we're just gonna connect to Spark. And as you can see here, we're going to connect to a local instance. Spark itself was designed to process large data sets on a distributed computers. So, you have like several tens or hundreds or even thousands of computers that are working together to solve a problem, computational problem. But, Spark happens to be so efficient that in these particular cases where there's a lot of data and doesn't fit into memory and you need to process data in your disk, Spark also helps a lot. All right, so we're connected to Spark and we were to look at the UI. One of the first interesting things to mention is that Spark by default only uses 1 gigabyte of memory. You can change this setting. As I was mentioning, I have 8 gigabytes available on my machine, but I'm gonna process all this data set in disk, so Spark shouldn't need that much memory. So 1 gigabyte, it's fine for now. So we're connected to Spark, and then the first thing that we want to do is we want to make sure that we can actually load this stuff properly. Just the 2 files that I generated from R. So in this case, we're going to use Spark read CSV, even though it's not exactly a CSV file. And we're going to load the small file first. And if we just do this, sorry, I forgot the connection. If we just do this, it's not quite there yet. What we actually want to do, as you can see here, the column is not being properly, divided by columns, and it's just being, a CSV is delimited by commas. So what we have to do first is change the delimiter. So you can just say delimiter equals, and then we're gonna do space. So now we're getting the right columns, but we actually don't have column names on this file. So we can specify the columns by saying, let's say 1 to 10. Now the columns need to be character strings, so we can just say that is columns C. All this is doing is basically generating a vector, right, with 10 columns. So we're gonna do this, and we're gonna say columns equals this, and basically this is loading the file into memory, into Spark with these 10 columns. Now this is not great for what we want to do, because if you look at storage, you can basically see that we're using 4 kilobytes of memory, and Spark in this particular context doesn't even have 4 gigabytes in this particular instance. We could process it in memory, but we're only going to use disk. So if we try to load, this particular dataset in this way, it's not even going to fit in Spark memory, which is good. So what we want to use is there's a parameter called memory, and you can force Spark when using R to not load stuff, not load the dataset by default into memory and keep it on disk. So we're gonna do this, and just for the sake of making sure that these work properly, let's just call this X. And now we wanna load dplyr, and now we wanna do our inner join. So we're gonna do X. Pipe. We're gonna pipe this inner join, and we're gonna pipe it with itself. This is just a test before we use the large data set. And we're gonna say by, and then we can pick one of the columns, C0. Let's see, C0, which is missing. Really? Let's see, what columns do I have? Oh, okay, so sorry, I'm starting with column 1, right? So it's 1 based. All right, so this is creating a join. And as you can see here, we get 10 records because we're basically joining something against itself, right? Which makes sense. Now, we don't want to return all the data, or we could save it into disk, after we do the inner join. I think, for this particular example, it would be more interesting just to see the count of records that are actually the same. All right, and yeah, this makes sense. Let me just check something. Let's just do X count. Yeah, it only has 9 records. I thought it had 10 records, whatever. So yeah, all the records are the same. So when we do the inner join, as I was mentioning here on Wikipedia, when we do the inner join, we're joining A with A, so we expect to have 9 records. All right, so this seems to be working. Yeah, so basically now all we need to do is we are going to replace basically this small file that we were playing with. We're going to replace it with this large file. Yes, that looks good. And we're going to call it x1. That's pretty much it. And as you can see, this operation was instantaneous. Why? Well, mostly because Spark is not doing anything at this point. It's just, we're saying, we're asking Spark not to load it into memory. So if we were to check our Spark UI here, and if we refresh these, you can see that we basically don't have anything in storage. Everything is basically on disk, which is good because we want to process this large data set in disk. So let's see here, we have job 31, that's the last one. And now we're going to repeat the join. And we're going to repeat the join here with x1 and x2 all together. And as you can see here, basically whenever we run this particular comment, what Spark is going to do is actually going to process all this data set that is disk-based only with the memory that it has available, which is less than 1 gigabyte. So yeah, this is pretty much it. Like Spark is working on the background, and it's going to take a few seconds to process this data set. But you can see here that there's already a job with 32, which is just starting. It has been processing for 30 seconds, 29 seconds. It has a few jobs running. You can see what Spark is doing, which in this case, you can see the inner join between the 2 data sets. And nothing seems to be in memory, which is what we want. My computer is definitely spinning on CPU. Probably you can't hear it, but it's definitely spinning. And yeah, it's still processing. It's in 49 seconds. And it's done. And the result, apparently, is that there is 0 elements in common between these 2 data sets. Now, this is likely because basically we just, when I mentioned that I was creating this data set, I use a pretty wide range of numbers. So here I'm generating 10 million numbers, but I'm multiplying them by 1 billion, and I have 10 columns. So it's actually pretty unlikely that we're going to have columns with exact same number, since I have 10 columns and I have several orders of magnitude here. So one of the things that we can do actually is let's just try something out. Let's just do it with the small data set. Let's just go back to the small data set, and let's just force the join to actually retrieve let's force the join to retrieve some data. So here we have x and count and inner join with x. Yeah, this is pretty straightforward. So if we wanted to like to force our join to actually work, well, not to work, it's already working, but if we wanted to force it to find some elements, what we could do is we could mutate the first set and say that the column 1, C1, and let's reduce just the range of, we'll do a floor. We'll do a floor just to reduce the range of these numeric values. And then we'll do the column 1 divided by 10 to the 4, I guess, maybe, just to make sure that we get a lot of repeated numbers. And then we should be able to do another mutate here. And then we're going to do again C1 equals floor 1 C1 divided by 10 to the 4. I think that's what I'm doing. All right, so we have two mutates that is basically just, in this case, is the same data set. I probably did something wrong. Floor 1. Yeah, that function doesn't exist. Just, yeah, floor 1. Yeah, here I have this typo. All right, this looks much better. Yeah, so all right, let's do that. But what I want to do instead when we run this is we're gonna do with x1 and x2, which are the huge files, the 2 GB files almost. I'm gonna make sure that we collect these. Well, actually, I want to make sure that we print them, because I also want to make sure that we measure the time. I want to make sure. No. I want to do system.time. I want to make sure that we measure from R how long is it taking to process this data set, and also print it, which I think it should work. Hopefully. All right. So now we're joining again the two data sets with an inner join. We're doing it all in disk. So this was our job 32. We should have a new one, 37. And again, it's going to take about 50 seconds. The plan should be quite similar. Actually, it is. I mean, it's the same type of inner join that we were discussing before. The only difference is that now I'm reducing the range of numeric values that are available in the columns. So we should definitely get some hits of, when we were looking at this join, the set of the numeric range was just too broad, and we're basically forcing it to get to overlap to be able to count some hits. All right, so this is still executing. Let's just take a look. Okay, it seems like it just finished in 41 seconds. And again, you can see here that this was processed in just 81 seconds, which is great. 41 seconds, also from the R side. And now we can see that we actually got some hits in this particular data set. There's about 282 million records overlapping in the total, 4 gigabytes almost data sets. And you can see that Spark was quite fast. I think honestly it would probably take even more than 40 seconds just to load everything into memory and convert it to a data frame in R and all that. Maybe I'm wrong. Definitely I haven't explored other tools, but I do think that this is a great use case of Spark when dealing with large data sets that either don't fit in memory or memory processing is not efficient enough for you to consider using Spark. Now, in general, I don't recommend, as I was mentioning at the beginning of this video, usually you don't want to use Spark with a single compute instance like your local machine, because Spark has an overhead for large-scale processing, and why not? But when you're dealing with datasets that are large, that they don't even fit in R's memory, you are definitely welcome to try Spark and R, and you should see improvements in most cases. The big caveat is make sure that when you load the data, you need to specify memory equals false on all the parameters that you use on Spark and all the functions to make sure that you're not loading anything into memory. And again, as you can see here, Spark didn't load anything into memory. And we can actually even look at how much memory Spark is using locally, and it's not much at all. Like it's under, it's not even peaked or whatever, and it's looking pretty great. Right, well, thank you so much. I hope this video gave you a sense of kind of like a corner case of using Spark with local datasets, and especially for those large datasets that can be processed directly in R. You can consider using Spark also for those local datasets and process all the data in disk. Now, it's always faster to process data in memory. So if you can load things into Spark or into R in memory, you're definitely going to see significant improvements. But for those cases where you can't, Spark on disk is a viable option as well. Thank you.